then we'll take a trip to Brazil. That's me on the far left there, and that's Dr. Walsh. We were both on an FPSO we'll take you to that was having some problems. So there we are in Brazil. This is the Beach of Piracema. It's an FPSO offshore in Campos Basin. I had visited the site for a produce limit exercise, and when I was there, I noticed they had the same design error, and I told them, you're not producing water now, but when you do, you may have an emulsion problem. And 2 years ago, I got a call. They said, we remembered you told us this might have a problem. We've got a big emulsion problem. In fact, when I got out there, it was so bad, they almost sank the ship because all the cargo holds were full of emulsion. So facilities, the main production train. Also see what the problem is. You get a centrifugal pump causing a lot of shear, and they're recycling all their stuff back to the front end. So deck drains, which may have oxygen in them, so you're going to corrode all your facilities. You got the lube oils, the slops, the tank bottoms, and the closed drain system. A big mess. This is the way to do it. They proved it when we were there. So when we first got there, this is what they were injecting. They had scale inhibitor and methanol at the front end, defoamers in different places, demulsifiers here, a biocide there, scale inhibitor. What we did is to shut everything off, and the system improved. Recommendations on this directly, these fluids to a different system. The system they had, and you can see they're doing the same thing. They're sending the hydrocyclone, flotation cell, all the deck drain stuff right back to the front end again, and that was a cause of the problem. So they had the same issue that Beach of Piracema had. Their solution was to put in a slop system to treat all this stuff, to separate the dehydration system, and then send the oil to sales directly. And again, people are willing to do things and allow engineers to operate and take advice when it's TINA, when there's no alternative, right? And they had no alternative. They were going to either have to shut in, haul an entire tanker load of oily waste away as hazardous waste, which I can't imagine the cost. But we brought in a separate small treating system to help them out. This is a troubleshooting checklist that you can use, and it just goes through, shutting the chemicals down, eliminating high shear things, doing compatibility testing, do bottle tests. One thing also, if you're recycling, are they recycling to the top of the pipe or the bottom of the pipe? Are they putting emulsion into the oil phase, or is it in the water phase? And again, my advice is you're not going to make this material in vast quantities. If you are, there's something wrong. So it's normally just a little bit, and if you can get rid of it through sending it through the sales line, just move it forward. Don't reprocess it, because if you reprocess it, it's a recycle. It is not going to go away. It's just going to get worse. So again, this is a oil treating, gas treating slide. But what you want to do is send any of the skims directly to sales. You don't want to recycle them to the inlet of your system. Okay, do another demo here on water cut. So it's the same oil, and by the way, if you'll notice, these oils will resolve after I shake them up pretty quickly. So you actually really don't need to add chemicals to any of this stuff. % water cut, 50% and 75%. So the question is, after we shake them up, does water cut have any influence? So the question is, which one's going to resolve the fastest? or which one's going to take the most time to resolve, the hardest one. It doesn't matter 50-50, 10%, or 90%. So actually the real answer is and we'll just show it to you, it's the one with the least amount of water. I want to take a look at the amount of time that we're going to be looking here. We're going to look at it less than a minute. So it's something surprising that you may or may not have known, and I'd encourage you to do these same tests with your fluids. And if you have fluids or if you have problems, witness the bottle test and see what's going on. Just in closing with this one section, a lot of this has to do with cooking. I don't know how many of you cook, but if you're going to make a vinaigrette, the recipe for making the perfect emulsion, which is what you want, is oil to vinegar of here, they're recommending 3-to-1. And then the other thing that you add to a vinaigrette is mustard seed, which is, well known from the Bible, the smallest seed. So it's very, very fine solids. So that's the recipe for disaster in our business on emulsions. In closing, I just want to go through some things that I've tossed in on as a little Lagniappe. It's French in New Orleans for a bonus or baker's dozen. Closed calculator that's free from HP. It's HP 41. I put in instructions on how do you install it. It works on all the Windows systems. Real easy. It's nice to have. It's an RPN calculator and it is programmable. In a paper, you might take some time to read. It's the 10 most common design errors on surface facilities in terms of spec breaks and spacing and corrosion. And it's an excellent SPE paper. And then kind of root cause failure analysis. There's a company called Think Reliability. It's thinkreliability.com. I put the tool in there. It's a free Excel tool, and it's great for brainstorming as well as documenting root cause failure analysis within teams. They've got free video webinars that you can click on that shows you how to use the tool, and then they'll also can do a training on how to do root cause failure analysis. But the thing I really like about it is after you subscribe, they'll send you once a month a problem, whether it's the Parkland City shootings or Macondo, where they've actually used the tool and shown how to do root cause failure analysis. And like anything else, the more you see the application of the tool and the techniques, the better you are at using them to get down to the root cause and make your company more money. Included is it's called an INC Buster. An INC is an incident of noncompliance offshore. EDG, an engineering firm in Houston and New Orleans, put this together. It's really good. It'll show you on your facilities if you have these safety devices installed. It's based off of API 14C, but it works onshore as well. If your device, if your pressure vessel, heat exchanger, compressor has these safety devices, you will pass any HAZOP with flying colors. So you can review designs, you can look at your existing systems. If you're working brownfield or if you're working surveillance, are the safeties appropriate? Do we need more safeties? Also, there's a copy of the latest CCPS beacon, and that's the website where you can get free every month issues of this. On this one, they're talking about maintaining a sense of vulnerability. You know, when offshore in facilities, you always want to have some chronic unease. You don't want to feel confident that everything's right. If you're always looking for what can go wrong, you'll have a much better safety outcome than just being complacent. All right, now it's time for questions.
Thank you so much for this presentation. If there are any questions, please feel free to turn yourself off of mute and have the opportunity to ask Jim any questions that you might have about the content he just covered.
Yes, sir.
Surprised me with the comment about centrifugal pumps being almost guaranteed to cause us problems and encouraging the use of gear pumps or recip pumps. And that was an aha moment for me, not so much a question as an observation.
And again, things work like they're designed, and normally a centrifugal pump will have a control valve downstream of it, and the combination of the pump and the control valve really shear the fluid and put in a lot of shear energy. It's a great way to make a margarita, I guess, but it makes a tight emulsion. And the other place that I see them inappropriately used is on the bottom of flare knockouts or process vessels that have fluids at their bubble point, because they'll cause cavitation. And when I see one, I'll ask the operators, do you have a lot of seal problems? And they go, why, yes, how did you know? And it's, well, like, it's the wrong application for the pump. You're welcome. The designers don't know. They'll just pick a capacity, and it's not something that's taught in college. And again, if you think of something and have questions later, don't hesitate to drop me an email or give me a call. I'm more than happy to talk with you. That's why I'm doing these.
All right, are there any other questions for Jim? Okay, well, thank you everyone for joining. For those who did call in, I will be sending the link with the information. And thank you very much for coming in. And again, if you have any questions in the future, please feel free to reach out to either Jim Langer or myself, and we'll be happy to help you. All right, everyone, have a great day.